Earth's true speed. How fast are we hurtling through the cosmos? You won't believe how fast you're moving. Right now you're probably sitting down watching this video. It feels like you're perfectly still, doesn't it? Well, maybe if you're on a bus or a train you feel that speed. But even if you're lounging on your favorite couch, relaxed and calm, get this. Right this very second, you are hurtling through the cosmos at absolutely mind-boggling speeds. Movement isn't just life, it's the very essence of our universe. Everything is in a perpetual dance, and our planet Earth? It's a full-fledged participant in this cosmic ballet. Let's embark on a dizzying journey, peeling back the layers to reveal your true speed through the universe. We'll start with the most obvious one, even though we barely feel it. Our planet is a giant spinning top, constantly rotating on its axis. It completes a full 360-degree turn roughly once every day. Sounds slow? Think again. Our Earth is a huge, albeit not perfectly round body, and every point on its surface is spinning right along with it. The fastest ride is at the equator. There you travel the full circumference in those approximately 24 hours. And the Earth's circumference is over 40,000 kilometers. Simple math shows that your speed of rotation at the equator reaches an incredible 1,676 kilometers per hour. That's about 1,041 miles per hour, faster than most race cars. Of course, the closer you are to the poles, the slower you spin with the planet. At latitudes like New York or London, that speed is already less, around 1,000 kilometers per hour or about 621 miles per hour. And if you were standing right at the north or south geographic pole, you'd simply be turning in place, not moving forward relative to the Earth's center. By the way, here are a couple of cool facts about our spinning planet. Because it spins, Earth bulges slightly at the equator and is flattened at the poles. This even affects gravity. You feel slightly stronger gravity at the poles because you're a tiny bit closer to the center of mass. And speaking of reaching space, launching rockets from near the equator gives them a free speed boost from Earth's rotation. And one more thing, the day is getting longer. Not by much, just about 14 nanoseconds per year, thanks to tidal braking from the moon and sun. But if you rewind time about 4 billion years to the early solar system, Earth was spinning 14 times faster. Back then, a day only lasted about 6 to 8 hours. Can you imagine what life would be like? Spinning on its axis? That's just the beginning. Our Earth isn't just a spinning top, it's also a cosmic race car, tearing along a massive orbit around the sun. The distance to the sun is enormous, about 150 million kilometers, or roughly 93 million miles, but we cover that distance at a breathtaking pace. It's the sun's mass that holds us in orbit and dictates how fast we need to move to avoid either falling into it or flying away into interstellar space. On average, Earth's orbital speed is nearly 30 kilometers per second, kilometers per second. That's over 107,000 kilometers per hour, or about 67,100 miles per hour. Think about that, 18.6 miles per second. Compared to this speed, our rotation at 1,676 kilometers per hour is just a snail on a drag strip. Our orbit isn't a perfect circle, it's a slightly elongated ellipse. So our speed around the sun actually changes slightly throughout the year. When we're closest to the sun, at perihelion, we move a bit faster, 30.29 kilometers per second. When we're farthest away, at aphelion, we slow down to 29.29 kilometers per second. A small difference, about 3%, but it's there. In our solar system, the fastest planet is the closest to the sun, Mercury, around 47 kilometers per second, or about 29 miles per second. And every planet moves slower the farther away it gets from the star, all the way out to Neptune, just 5.4 kilometers per second, or about 3.3 miles per second. It's a cosmic race where speed is determined purely by the star's gravitational pull. But the sun isn't sitting still either. Our sun is just one star among hundreds of billions in our magnificent Milky Way galaxy, and all these stars, including our sun and its entire planetary entourage, are moving along their colossal orbits around the galactic center. We're located quite far from the galactic center, roughly 27,000 light-years away, and even at that distance, the gravity of the supermassive black hole and the entire mass of the galaxy pull us along. One full orbit around the Milky Way? That's an incredibly long trip. It takes about 220 to 250 million years. To give you a sense of scale, the last time our solar system was in this same spot in the galaxy, the first dinosaurs were just starting to appear on Earth. In its entire history, our Earth has completed about 20 of these galactic laps. That's roughly how many times we've celebrated a galactic New Year. So, how fast are we speeding on this giant galactic carousel? It's estimated that our sun's speed around the center of the Milky Way is about 220 kilometers per second. That's roughly 492,125 miles per hour, or about 137 miles per second. That's about 7 times faster than Earth orbits the sun. Can you wrap your head around that? 220 kilometers, roughly 137 miles every time you blink. This speed is actually one of the hardest to measure precisely, and it has an uncertainty of about 20 kilometers per second, or about 12 miles per second. We know it with roughly 10% accuracy. Cool fact: the plane in which our planets orbit the sun, the ecliptic, is tilted about 60 degrees relative to the disk of the Milky Way. So depending on where Earth is on its orbit right now, moving forward along the sun's path or backward, our speed together with the solar system through the galaxy actually changes slightly, varying roughly between 208 and 237 kilometers per second, about 129 to 147 miles per second. Think the Milky Way galaxy is just sitting still in space? Think again. Our Milky Way is just one part of a small cluster we call the local group of galaxies. It includes about 60 gravitationally bound galaxies, and the largest one, our big neighbor, is the Andromeda Galaxy, located about 2.5 million light-years away. And guess what? Andromeda is moving straight towards us. We are on a collision course. Don't worry, the Great Galactic Merger won't really get going for about 4 billion years. But the fact is, we and Andromeda are rushing towards each other. By measuring its speed from the shift in its light spectrum, scientists determined Andromeda is approaching the Sun at 301 kilometers per second, which is about 187 miles per second. Taking into account our own Sun's motion within the Milky Way, it turns out the Milky Way and Andromeda are hurtling towards each other at about 109 kilometers per second. That's roughly 68 miles per second. But our cosmic flight doesn't end there. The local group of galaxies isn't an isolated island, it's moving too. Why? Because the universe isn't perfectly uniform on the largest scales. Some areas have more matter. These are the giant clusters and superclusters of galaxies. And some areas have very little matter. These are vast, empty regions called voids. These giant clumps of matter have colossal gravity and pull everything towards them, including our local group. And the voids, being less dense, exert less gravitational pull, which, from the perspective of relative motion, acts like a gravitational push. Imagine this: one side of us is being pulled by a massive supercluster, and the other side is being pushed away by a giant void. Both these influences essentially work in the same direction, causing our entire local group of galaxies to rush at an incredible speed. Calculations show that the speed of our local group relative to these largest structures in the universe is roughly 600 kilometers per second. That's about 1,342,160 miles per hour, or an astonishing 373 miles per second. Your true cosmic speed. So there you are sitting, but Earth is spinning. Earth is orbiting the Sun. The Sun is cruising through the galaxy is moving within the local group, and the entire local group is flying under the influence of gravity from the universe's largest structures. How do we add up all these speeds to find your true speed? Scientists have a kind of ultimate reference point, a cosmic zero of motion. It's the cosmic microwave background, or CMB. This is ancient radiation left over from the Big Bang that fills the entire universe uniformly. It acts like a stationary cosmic backdrop. By measuring tiny variations in the temperature of this background across the sky, the Doppler effect, like a cosmic wind blowing in the direction we're moving, we can determine our speed relative to this backdrop. Adding up all the components of motion, Earth's rotation, orbit around the sun's movement in the galaxy's movement in the local group, and the local group's motion relative to the large-scale structure of the universe, scientists arrived at an astonishing number. Your total speed through space right now, relative to the cosmic microwave background, is about 368 kilometers per second. Get this, 368 kilometers, or roughly 229 miles, every single second. Every second you spend calmly sitting on your couch. This speed is directed roughly towards the constellation Leo, and it changes slightly throughout the year by about 30 kilometers per second, about 18.6 miles per second. Because Earth's motion around the sun is sometimes added to and sometimes subtracted from the sun's speed relative to the CMB. The accuracy of measuring our speed relative to the CMB is incredibly high, with an uncertainty of only plus or minus 2 kilometers per second, about 1.2 miles per second. It's one of the most precise measurements of our cosmic motion. Using the full set of measurements, scientists can even calculate the motion of the entire local group of galaxies relative to the surrounding large-scale structure of the universe, using the CMB as the ultimate reference. That speed is about 627 kilometers per second, roughly 390 miles per second, with an uncertainty of plus or minus 22 kilometers per second, about 13.6 miles per second. Interestingly, most of the uncertainty in this number comes from how hard it is to precisely measure the speed of our sun orbiting the galactic center, the most difficult part of our multi-layered cosmic motion. Conclusion: you are part of the great cosmic dance. So what does all this mean? It means there is absolutely nothing in the entire universe that is simply standing still. There is no static, motionless corner. Absolutely everything, including you right now, is participating in this magnificent, multi-layered cosmic ballet. You are a passenger on an incredibly fast carousel, orbiting a giant star, which, along with billions of other stars, is swirling around the center of a massive stellar island. And this island is rushing towards its neighbor, and this whole company is flying through the void under the influence of invisible gravitational forces left over from the very beginning of time. Every day, every hour, every second, you are traveling millions of kilometers through space, often without even realizing it. It's captivating. It changes your perspective on familiar things. It's a powerful reminder of just how dynamic and incredible the universe we inhabit truly is. In the future, as we create better maps of our own galaxy and measure the motions of other galaxies with more precision, we'll be able to predict our cosmic path with even greater accuracy. But one thing is clear already: our place in the universe, it's a place of motion, always. It reminds us that movement is an inseparable part of our existence. If you enjoyed this cosmic journey, please give this video a thumbs up and subscribe to our channel. See you in the vast expanse of the universe and in our new videos.